Alright, the first chapter name is Java Building Blocks. Okay, I'm going to save your time and my time because I went through every lecture of this document already. I mean, till that session I'm making for this in this video. Okay, understanding the Java class structure. As I said before, you should have some basic knowledge on Java. Then that would be really helpful for this video. That would be a lovely thing to go through this video in fast. So, an object is a runtime instance of a class in memory. What is an object? This is pretty much a straightforward answer. I highlighted for you, and the rest of the details you don't really need. Saving your time, right? An object is a runtime instance of a class in memory. What does it mean? An object. When you compile a class and an object is created, right? An object is a runtime instance of the class in memory. And the next point, all the various objects, all the different classes represents the state of your program. So the 2 points, important points are, an object is a runtime instance of a class in memory. All the various objects of all the different classes represents the state of your program. Your program might have one or many classes. So all the various objects of all the different classes represents the state of your program. I hope you are clear till here. And the next is fields and methods. Together, these are called the members of a class, right? Does it make sense? Java classes have two primary elements, methods and often called functions or procedures. In other languages, they're called as functions or procedures. But in Java, we are going to call them as methods. A part of that, and fields, more generally known as variables. So fields are known as variables in Java. Together, these are called the members of the classes, right? What does a class contains? This class contains fields and methods. That's all a class contains. So together, these are called the members of the class. Variable holds the state of the program and method operates on that state. We are pretty much clear. Fields are called variables and the functions are called methods. So what are the variables? Variables hold the state of the program, right? And what are these methods? The methods operates on that state. That's it. And this is a basic. They're trying to give an overall structure and provide a variable name. Over here, we defined a variable name and name. So in this, they provide a small program which contains a string name in a class animal and a public string get name, just like a setter getters for the name. So get name returns name and has a public access modifier and string as a data type, and the public void set name. Here we are passing the string new name as a parameter and we are assigning the name to this new name. So what's happening here? So a string is a value that we can put text into, such as this is a string, right? This is a string is something we can put in this name string. A name is a variable, right? String is also a class supplied with Java. So what is a string? Remember this point that string is also a class supplied with Java. A method is an operation that can be called. That is pretty much a method as we discussed before. When you observe this program, there's nothing that big thing to discuss in detail. And the next thing after the fields and methods is the comments. What is comments? Another common part of the code is called comments because comments aren't executable code. There are three types of comments you already know. A single line comment begins with 2 slashes just like this. A multi-line comment includes anything starting with a simple slash asterisk and asterisk followed by backslash. So in this way, these are called multi-line comments or multiple comments, whatever it is. And we have the third type is called multi-line comment. It starts with slash star star like over here. This is called a multi-line comment. Okay, but there is a specialty with this kind of comment, that is this specifies Java doc comments are also called as multi-line comments. So Java doc comments have a specific structure that the Java doc tool knows how to read. So when you find this kind of messy things, don't get annoyed, stay cool and just try to figure out what's going on. This is a single line comment, even though comments technically aren't on the exam, so that is a positive thing, so don't really worry about that. And the classes versus files. Java class is defined on its own .java file, and when we compile this, we'll get a .class file. Writing a main method, a Java program begins execution with its main method, right? A method is a gateway between the startup of a Java process, which is managed by Java Virtual Machine (JVM). So this is a very big point to remember, because when someone asks you in the interviews or in the exams, what is main and what's going on with that, so which is managed by the Java Virtual Machine. Main is something, so Java Virtual Machine search for this main and get started executing. There are a lot of things like static block, instance block, forget about that, but just we are talking about the main method, so which is managed by Java Virtual Machine. So main is nothing but declaring the entry point of the particular class. And then to compile Java code, the file must have the extension .java. The name of the file must match the name of the class, right? That is a basic thing, very important thing in Java. The result of this file of bytecode by the same name, but with a .class file extension. So when we get the bytecode, it's not in like .bytecode or some format. The bytecode is something which is in the format of .class file name extension. Bytecode consists of instructions that the JVM knows how to execute. That is the beauty of the .class file. So if you take this .file, if you run on my machine MacBook and take it and run it in a Windows, it works fine. That is called the bytecode. Note that we just omit the .class extension to run zoo.java, because the period has a reverse meaning in the JVM. So this is the basic two commands to run any program. Java C, it is letting Java know that to compile this zoo.java, if you have a program with a zoo name or whatever it is, this is a way to execute the command. And if you are familiar with the any IDEs, then that is much simple, like just right click and executing the program. So Java C, asking the compiler to compile the .java file, and Java zoo, asking the JVM to execute this program, run this program, and we'll get the .class file. Okay. Java doesn't need to create an object to call the main method. JVM search for the main method. Actually, it doesn't need to create an object to call the main method. This is a beautiful point to remember, so I highlighted in the yellow. Even if the main method is present, Java will throw an exception if it isn't static. A non-static main method might as well as be invisible for the point of view for the JVM. I will just repeat this point just to be clear. Even if the main method is present, so we have a class and a main method, Java will throw an exception if it isn't a static. So in the public static void main, if there is a no static word, it kicks out an error. A non-static main method might as well as be invisible from the point of view to the JVM. So in the previous point, we learned that JVM, which is managed by the JVM Java Virtual Machine, right? So that is because of the static keyword in the syntax of main method. And then there are few ways to mention this string args in the inside as a parameter in the main method. They are this following ways: string args, a traditional way we all use, and placing this braces after the args will also work, or this is a new way which came in Java 7, providing 3 dots, string dot 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 args. And then these are nothing much to discuss, because they are just trying to explain us how to compile and execute a program. And then understanding the package declarations and imports. We all know, right, how to start open a class and where to mention the package name. And then just so you know that we'll have a import and then have the class, and before that we'll have a package name on top, and then after the class we will have this main method. There is no necessary that it should follow these steps. After when the class is opened, they can be jumbled also. In this example, we imported the java.util.random because we use a random key here, and we have imported this and a pile of other classes also. So this asterisk says that, hey Java, get me all the classes in this package util, right? So that the star is in wildcard that matches all the classes in the package. Just like I said, it does not import child package fields or methods. It imports only classes. That is pretty much clear over here. Remember that it doesn't import child packages, fields, or methods. It just imports only classes. Okay, it's only classes for now, but there is a special type of import called static import that imports other types. And he said that we will learn more about that in chapter 4. So don't worry about that. Just remember till the point we discussed. And then we are discussing something about the redundant imports. So what does this guy wants to tell here? So if we have a specific import or a wildcard import and using the same class, you don't need to memorize. So the good thing is you don't need to memorize these packages for the OCA exam. You don't need to uh, learn all this or memorize all these classes, which class contains which methods and all for this exam, because that's quite impossible for anyone to remember. Here I want to discuss something important. So if we are trying to access a class which is present in two packages, so they have given beautiful example over here. We are trying to access the date. Okay, the answer should be easy by now. You can't write import java.util.star or java.util.date. The tricky cases come about when other imports are present, right? It's not a big deal if you have an asterisk here or a detailed class name here, but the tricky thing comes when the same date class we are trying to access is present in SQL, java.sql.package, and also it is also present in util package. So which package class function we are going to use? That is an ambiguous situation. In our example, the solution is easy. Remove the java SQL dot date import, and then we don't need. But what do we do if we need a whole pile of other classes in java.sql.package? That's really a beautiful question. We will look on that over here. Now it works. If you explicitly import a class name, it takes preceded over any wildcard present. Java thinks, okay, the program really wants me to assume use of the java.util.date class. One more example, what does Java do with tries of precedence? So here these guys are trying to use the same date class in two different packages. Java is smart enough to detect that this code is not good. As a programmer, you will claim to explicitly want the default to be both the Java util date and Java SQL date implementation, because they can't be two defaults. The compiler tells you import java SQL.date collides with another import statement simply. If you really need to use two classes as the same name, so he has given a complete class over at the top and public class conflict date and java SQL.date he has mentioned inside the class. This is how we handle the situation. Or you could have either with the imports and always use the full qualified class name like this: java util date java SQL date with a different variable. And the same thing we are trying to discuss, what is a jar. It's just a combination of all the java files, just an archive file. So here is a point I've noted for you guys. You were just being asked if the part of the code you are showing compiles when dropped into the valid server code. So this guy wants to tell that we will have a question starting from the sixth line or some other line to some other line, and here we are missing the class name, right? And also the import statement. So this guy is trying to tell us in this document that don't worry about the code about don't worry about the imports, don't worry about the class names and all. If they are given this kind of code, try to concentrate on this code only within the mentioned and try to imagine the rest above or the rest below. And then constructor, here we go. So we are talking about the constructor. And what is a constructor? It creates an instance of a class. All you have to do is write new before it, right? Here r random r equal to new random. It means that an instance is given, an object is created for the random, and the object name is r. Okay, hope you're clear. The purpose of the constructor is to initialize fields, as I said before. If class have some kind of fields, like let's suppose we have a class chick and the public chick without any data types, that means no return types at the end. And public check must be the same with the class name, and this is called a constructor. That is pretty much. And if you have a class chicken, and these are the fields in the class, right? Int number of x equal to 0, they have initialized the integer number of x with 0 and the string with the name, but they haven't declared anything to this string name yet. So we are trying to make a constructor here, public chicken, and the name equal to Duke. Inside this constructor we have initialized the constructor. We provide some value to that variable. Hope you are clear. So what's this? Reading and writing object fields. Reading a variable is known as getting it. The class gets number x directly to print out. Writing to a variable is known as setting it. So here we have a class. So this guy over here is talking about the code over here. So public class fan is a class, and it has a instance variable that is number x, and you haven't assigned any value to that integer. And we have a main method here, and we are trying to make a instance of this class like swan mother equal to new swan. This is a variable name holding this object of this class, so it can be anything. Mother dot number of x equal to 1. So here they set a value for this number of x which was declared after the class, and sys out and printing the mother dot number of x. So here what is this point is doing? Here is setting a value to a variable, and what is this line is doing? So in this line it's reading this value or this variable and also displaying it. So this is reading. So here we are setting. There are two things, setting and getting. Reading a variable is known as getting it. The class gets number of x directly to print it out. Writing to a variable is known as setting it. That's a very small point, no need to get confused. Instance initializer block. So what is this? Sometimes the code blocks are inside a method. They are run when the method is called. You already know what is an initializer block. The code in these two curly braces is called initializer block. So you might find this kind of code in a class or in a method. So if it is in a method, then that executes if the method is called, and if it is in a class, that gets executed even nothing is called. I mean, if no one is calling that, how can you call a block of code which doesn't have a method name or some value to it? So whenever JVM executes it, it executes this initializing block. Order of initialization. Two important points to keep in mind: that fields and instance initializer blocks are run in order in which they are appear in the files. The constructor runs after all the fields and instance initializer blocks have run. Let's look at this example. Public class check, private string name. They are assigning a value to this variable, and this is a look at this. This is called a initializer block. System.println of setting fields. Okay, so as soon as JVM enter into the class, it displays this field. First statement in the console, and we have a, oh look at this, we have a constructor here and assigning the name tiny, value tiny to this name which is defined as a fluffy. It's overriding in the constructor. Then we have a print statement here and setting the constructor. Okay, and we are not worried about this constructor yet because we haven't gone into the main method yet. So when the JVM gets into the main method, it checks this syntax and get into that, and there is a object created. So what does it say? It's a constructor. So it gets into the chick, and it looks at this name equal to tiny. Okay, I got this name reassigned from fluffy to tiny. Okay, it's just assigned, not printing anything yet. And then display this thing. Okay, because a constructor is called and the entire thing block of code in the constructor need to be executed. So it's reassigned the fluffy with tiny, and then prints this statement setting constructor, and then comes back because the block of code is executed in the constructor and executes the next line. What does it say? Oh, it's a print statement. Okay, what does it print? It's a chick dot name. So what is chick is currently assigned, name is reassigned with tiny. So what will be our output? Our output will be setting fields first, and then setting constructor second, and then third will be tiny. Look at this. That's what we just discussed. And then look at this example over here. We have a class egg, and when we have a constructor defined inside that and a main method. So what did I say? When my JVM enters into the class, it doesn't execute the constructor yet before, because that will search for the main method, and it looks at this object creation. Okay, we have a constructor, so it gets into this egg, and it considers, okay, we have a number equal to 5, which is not defined anywhere else because it's just a local number equal to 5. What does it mean? It means nothing. And we are trying to display egg dot number. Okay, and the private int number is defined over here. This number is reassigned with 5 in the constructor. And this is also, look at this, there is also a initializer block number equal to 4. This is quite tricky, right? So let's go in a flow again. We have a class that when we get into the class, we have instance block given as first reference. So number equal to 4, keep it aside. We are not printing anything yet. And it goes into main method and creates the object, and in the object, the constructor, and the constructor we are assigning it at 5. And then ultimately we are trying to display egg dot number. I believe in the console we get the number printed as 5. So let's look at this statement. If you answer 5, you got it right. Ooh, yes. Fields and blocks are first run first in order setting numbers 3 and 4. Then the constructor runs setting number to 5, just as we discussed. So when we jump to the primitive types, we all know this thing, right? Java contains primitive types and reference types, so different object and primitive types. Here the thing we have to notice is that float requires the letter F. So if we have a floating point declared or assigned at a particular variable, then don't forget to have a F at the end of this value. And we all know what all the primitive types. Look at here. The solution is to add the letter L to the number. When you have something long mentioned, long data type, and have a variable, then please don't forget to have a L at the end, as we have F for the floating point and L for the long. Okay, and look at this. Here they have given a brief description of what actually B is worth, A is worth, and 59 is worth right now, but you can definitely look at this. Pausing the video, you can have underscores in the number to make them easier to read. So from Java 7 update, we can have underscores in the integer field. Remember, you can also have a decimal in the double, and make sure value doesn't end with the underscore or start with the underscore, or have a immediate underscore after a period. It should be in this way. I mean, this is valid double state, or this is valid integer. Don't mix it, which is completely meaningless, like underscore and a period. It doesn't mean anything. And reference types. So there are two things we have discussed: primitive types and reference types, right? Reference do not hold the value of the object like variables do. Instead, reference points to an object by storing the memory address when the object is located. The concept referred to as a pointers. Like in C and other languages have pointers, Java have these reference types similar to the pointers. What is a reference? So this is a beautiful diagram he tried to illustrate. An object in memory can be accessed only via a reference. So if you have a variable today and we are assigning a date to that reference, then it is called a reference. It is referring to some address, right? And we have a greeting here and have a how are you string assigned to this. So when we look at this, a date contains day, month, year. So today is something, a reference that is referring to this object, and greeting is a reference that is referring to this object. So something which is referring to an object is called a reference type. Key differences. What is the difference between a reference type and a primitive type? The reference type can be assigned null. So here, today equal to null, greeting equal to null can be done, which means they do not currently refer to an object, right? If they are assigned to null, what does they refer to? Nothing. Primitive types will give you a compile error if you attempt to assign them to null. Int s equal to null does not compile because integer is a primitive type, and string s compiles fine because it's a reference type, right? So it's not a primitive type. Next, reference types can be used to call methods when they do not point to null, just as we discussed. Reference types can be assigned to null. If it is assigned to null, then they are not referring to any object. Primitives do not have methods declared on them. Okay, if you are not clear, let's go through this example. String reference equal to hello world. it compiles fine because we are referring the hello to this reference. Int length, this is a length. Int length is a primitive type, so reference dot length, they're calling a length method, but still it's a value. The length of the hello will be here to this int length, then the length will be 1 2 3 4 5 5 will be the length. So if you are trying to have another integer primitive type and trying to display the length, so length, here we are trying to find the length of this object, not the phi, so it does not compile. Hope you understand this. That's a gibberish example, but still we discussing a boolean b1 b2 string s1 equal to 1 and s2. I think this is fine, double d1 double d2, this is also fine because they have the same data type but two variables associated to that data type. Int i1, it's fine, int i2, it's fine too, int i3, this is all fine. So wait, what does this guy say? The third statement is not legal. Java does not allow to declare two different types in the same statement. Okay, then the E must remove this double over here, and that should be good enough. What else do we have here? Identifiers. What is an identifier? The name must be like a naming constraints they are talking about. The name must begin with a letter or a symbol, and the symbol can only be dollar or underscore. Subsequent characters may also be numbers. So after a letter or dollar or underscore, they can be numbers. You cannot use the same name as Java reserved word. As you might imagine, a reserved word is a keyword that Java has reserved. So that you are not allowed to use it. Remember that Java is case sensitive, right? So you can use version of a keywords that you have differ in case. Const and to go aren't actually used in Java. They are reserved, so people coming from our other languages don't use them. So they have listed all the keywords over here. Look at these identifiers. OK identifier is fine, dollar is fine, underscore is fine, and this is also fine, but this is not fine because they have a 3 starting with. This is not fine. And what else? Hollywood at the rate, they have a at the rate. This is not valid identifier. Asterisk is also not a valid identifier, and public reserved word cannot be used as an identifier. Most Java developers follows this convention for identifier names. Method and variable names begin with a lowercase. This is very basics of Java, you all might already know. Class names begin with uppercase letters and followed by camel case. Don't start any identifiers with dollar. The compiler uses this symbol for some files. Local variables. A local variable is a variable defined within a method. Not valid is a method, and we have declared all this. So here these are valid just within the method, and they have to be declared. The variables inside a method should definitely be initialized with a value, otherwise the compiler doesn't compile and kicks out an error. So here we have a variable y of data type int given 10, and x is not assigned to anything. Here in the method we don't have a compiler to assign the object or values, right? We explicitly need to add a value to the variable. So if you had this 2, it doesn't compile, but in class level variables they are fine, it compiles fine. Instance and class variables. Variables that are not local variables are known as instance variables or class variables. So these are all the default initializing values if the variables are class level. So boolean, it will be by default false. Remember this point, don't consider it as a true default value for boolean if it is in class level. Byte short int long will be 0, float and double will be 0.0, char will be null. If it is hard to remember this, remember as null. All object reference will be null. Understanding the variable scope. So variable scope of this is within the method. It is only available for use in the if statement because it is declared inside of it when you see a set of braces in the code. So this guy wants to say that, look at this example. This is a method, starts at line 16. It means that there are plenty of code above line 16. So let's consider this method. Hungry is a parameter passed to this method, and if hungry is true, then we are declaring a local variable with a value 1 and also a local boolean with true, and we are trying to print the local value. It's fine, till here it's fine. And when we try to print out the tiny bits, which was a local variable for this block of code, so this cannot be used by the outside block of code, so it doesn't compile. That's what is trying to tell. Hope you all guys are clear till here. So let's look at this. He's talking about the sequence of the structure of Java basics. So he wanted to tell us that import statement should be first, and the package structure. Okay, let me be clear what I'm talking about. So he wanted to say that this is a sequence of things should be like package name, and then the import statement, and then the class, and then the value, a method. So if someone writes a code in this manner, import statement, package should be first, and then the string name, which doesn't make sense, it's not even a class or a method, and then the class. So it doesn't compare. Think of acronym pic, a picture. Pic means package, import, and a class, PIC, packaging. What do you think when you talk about destroying an object? It's called a garbage collection, right? All Java objects are stored in the program's memory heap. When you talk about an object, it's stored in a program's memory heap. It's garbage collection. Garbage collection refers to the process of automatically freeing memory on the heap by deleting objects that are no longer reachable in our program. Automatically freeing memory on the heap by deleting objects that are no longer reachable to our program. Generally, people are quite familiar with this system.gc method. Java is free to ignore this request. Highlight this point. So garbage collection is something, a tricky thing that it's completely a villain wish of JVM. So remember these 2 points. The object no longer has any reference pointing to it. All reference to the objects have gone out of scope. These are the 2 conditions when garbage collection really clears the space of an object. So he's trying to explain us based on this program, public class scope, and scope as a main method, string 1, string 2, 2 local variables. One is assigned with a new string A, new string B. 2 objects are created because we have 2 new keywords. So we have 2 objects, and 1 equal to 2, 1 equal to 2. So we don't really need 1 anymore. I mean, A is gone. We are just having B referring to 1 and 2, and string 3 equal to 1. Now string 3 is also pointing to 1. That is, every variable like 1, 2, and 3 are pointing to B, and then 1 equal to null. So this guy is talking on this program. Like I said, A, B, and 1, 2, and 3 are pointing to B, and then finally cross out the line. He is trying to help us how to imagine those conditions. This means B doesn't go out of the scope until the end of the method on line 9. What does it mean? Line 9, the B doesn't go out of the scope, and so garbage collection don't delete this object until the end of the program. He is trying to make that point clear. And the finalize method, in practice this means that you are highly unlikely to use it in the real project. Luckily, there isn't much to remember about the finalize for your exam, so it's a good point to not to care about this anymore. Just to keep in mind, it might not get called, and that is definitely won't be called twice. This is important point, that if you call a finalize method, it may or may not be called, but once if it's called by JVM, it won't be calling again. And this is a summary, and a point I have noted in the summary, that is, instant variables are the non-static fields of our classes. Class variables are the static field within a class. Okay, the instance variables mean the block of variables present in the block of curly braces, and they are non-static fields of a class. And class variables are the static fields within a class. This is pretty much, we completed the very first session, and here is a review question. I'll try to make another video if you're tired enough to watch this, and thanks again. Bye.